So the final chapter of our lessons is the software, as you know, and we started last week already. And today we will continue. So let's share the screen and continue with the hardware.
Hocam.
Yes.
All-Learn'e son yükledikleriniz ödev mi hocam?
All-Learn'e yükledim sanıyorum. Hardware yüklenmiş mi? Baktınız mı?
Yüklenmiş de parantez içinde homework gibi bir şey yazıyor ama.
O başka. Homework. Bir dakika. Homework olmaması lazım ya. Yanlış bir şey mi yaptım orada? Bir dakika bir bakayım ona.
Bu derste ödev olarak sadece slide var değil mi hocam?
Sadece slide var, evet. Şimdi bir dakika bir döneyim oraya ben tekrar.
Content design.
Content'te neler var?
Şu parantez içinde
Hardware'i yüklemişim ben, evet. Hardware'i yüklemişim. Sadece software yok. Efendim?
Tamam. Sınav hardware'e kadar değil mi?
Evet. Hardware burada, evet, doğru. Aynen. Sınav hardware'e kadar, evet. Hardware'i dahil etmiyoruz. Hardware ve software ikinci sınavda, yani finalde olacak.
Bu hafta da online mı devam edecek hocam dersler?
Bu hafta yani her halükarda online devam edecek de sınıfa gelen olursa onlarla yapacağız. Açıkçası pek gelecek olur mu bilmiyorum. Bugün gelmediğine göre gelmezler herhalde yani öğrenciler. Herkes
Yarın
olduğu
sabah
yerden.
machine design dersi var ya hocam bizim, o yüzden sordum da.
Efendim?
Yarın sabah machine design dersi var ya, onun için sordum.
Evet, yani machine design dersi var. Sınıftan mı yapacağız, online mi yapacağız? Açıkçası
ben
şey olacak.
İzmir'den gelip gidiyorum da hocam, o zaman gelmeyeyim hiç. Eğer.
Yani her halükarda online olacak. Yani bu şöyle denildi. The official announcement is following. So lessons will be online, but also in the class. So that means the students who came to the class, they can see me, but and they can listen the lesson face to face. But also they have the opportunity to let's say access the lesson by the All-Learn and continue with All-Learn. It's all of them as possible. Yani both of them are possible. So, and there is no let's say the obligation that you have to come to the lesson, or you have to take the lessons online. It is free for the students. Okay?
Okay, thank you.
Any question? So, okay. So that's that. We will. I've been informed that from the university that the lessons will be face to face, but also online. That means for me, I will do the lesson online I will do the lessons on All-Learn platform, but in the class. So, but I'm also considering if nobody will come to the class, so I sit in the class and make the lesson online. It has also not any meaning, huh? After midterm. Okay, then Shall we continue tomorrow online? What do you mean? What do you think? Tomorrow in the morning. Okay. So if somebody, let's say, interested to come to the class, so I will come. Okay, no problem. I can come and I can make the lesson in class. But please inform me about if somebody will come to the class, and therefore I will organize accordingly. But if not, I can execute the lesson also from my home office. Okay, next week we will midterm, and midterms will be also online, so not face to face. It is, I don't know, it is also for me confusing, but let's do the best, huh? Let's do our best. Okay, and another issue is following. So you know, you have two different midterm date defined. For one for principle of mechatronics, the other one is what was it? Equipment and the measurements and components and measurements and in mechatronics and so on. And for the mechatronics students, for the mechanical engineering students, Mechatronics 302 and mechanical engineering 320. They defined two different exam dates, which is not acceptable from my side. It is a mistake, and we are going to correct it, to let's say, to change it so that on the same day both the students from mechanical department and from mechatronical department will participate to the lesson. I am working on that with the Dean Office. It is not defined, and if it is defined, so you will get the information. If not, we will keep what is defined. Okay. So the exam date is, let's check when we have the exam. So according to the actual definitions, principle of mechatronics, we have 10th of April between 8:50 and 10:20 online, and the same day mechatronic component and instrumentations, that means mechatronics 302, will be in the afternoon, on the same day, in the afternoon, 12:30 till 14, which is which is confusing because we do the lessons together, or same content, same lesson, but different coded. So therefore, I'm trying to take the lessons, bring the lessons into the same day and time, and then machine design we have on Tuesday. That means the 11th of April, and then in 12th of April we have two exams. One of them is theory of machines. The other one is static in the afternoon. Static is between 14:10 and 15:40. and at the same day, theory of machines is between 10:30 and 12. So let's wait whether we have any decision or not. If not, we will keep as it is. So then let's come to the okay, to the lesson. Software, okay. So after midterm, you will start to that means so let's check it. The homework presentation. The homework, okay. Here we have homework. So the deadline is 12th of April. So that means 12th of April. Let's check the calendar.
Hocam herkes aynı gün mü yapacak? Teslim edecek.
Not on the same day, but we will start with the group A, B, C, D, and we will continue. So
Yani 24'ünde grup A mı hocam?
yes, group A will start. Actually, we have to start. So we have to. So the exam, we finish the exams at 14th of April, and then or we can start actually with 17 and continue with 14 because we have after exam we have 3 weeks, huh? So 1 and 3 weeks. Okay. Also from your side, is it the same calendar you have?
Hocam actually I think the dates will be changed because of the direct.
Yes, Hocam, I think they will change dates. They not say anything, but I think they will change.
Change what?
I mean
when semester will finish.
It will be expand or what they think?
Yes, I think it will expand, but I don't know.
Okay.
Because we have two-week break.
2 weeks more. Okay, let's see.
Yes, probably 2 weeks more.
2 weeks more. So let's wait for the decision. Okay, then we can start. I mean, okay, we will start at 12 as it is as we decided already. Deadline is 24. So 24 we start the presentation with the group A, and we will continue. Okay, let's continue the lessons. So, can you see the PPT presentation? Yes or no? Because I cannot see your message. Okay, so I have seen. Thank you. So let's continue. Huh? So we were somewhere here. So we started already, and we said that the PLC programming software, we are going to talk about the programming software. That means the languages we are going to talk about, we use to explain the hardware, I mean the PLC, what we are going to do regarding regarding our system, that means the automation. And we said the hardware to communicate with hardware, there are several PLC languages developed, and one of them is the statement list, the other one is the ladder diagram and the function chart, matrix programming, basic language, and also there are some other languages. So, and the companies using, the companies as in producing the PLCs, they are using these type of programming language. Some companies producing their own programming language, user software, like Siemens, for example, because Siemens has a big market share, and because of this reason, Siemens developed its own programming language. And if you use Siemens PLC, so then you have to use the Siemens software to write the program. But also possible, I mean, in this is programming in statement list or ladder diagram or function chart and so on. Okay, then we said statement list. So let's start with statement list and statement list. What is the structure of the statement list? Structure-wise, we can say statement list elements, step, sentence, conditional parts, and the executions part. So step is an interesting structure. That means you can divide the program, main program, mainly you can divide the program in certain steps, depending on the structure or depending on the frame of your program. So you can divide in certain steps, and you will execute or you will write the program step by step. Let's say it starts from the step 1 and goes step, let's say, to the last one. And there are sentences within the steps, and these sentences mainly consist of two parts. So conditional parts and the execution parts. And conditional parts, as it is also, it can be understood from the definition. It is something related to the conditions. For what? For the execution. So in each steps, you have to execute something. This is the target or the, expectations from the software. But for the executions, it needs some conditions. So if the condition is okay, then the program sentence will be executed. If not, they will not execute. So therefore, we talk in our last lessons, execution means, so what is executions? So, check condition first, the conditional part, the condition parts like this here. So, and it is the section of the sentence where the conditions, so the conditions are required. So conditions are required before you can activate the execution, before the execution. So here are the examples. If, let's say, input 0.0, that means you may remember from our hardware lessons, the hardware has certain inputs and outputs, or input module and output module, and input module consists of several inputs address, and one of them is the, let's say, input 0.0. The other ones maybe 0.1 and 0.2 and so on. So in these examples, say if input 0, 0 and that means end, I mean continue. If not T1, that means timer. We already also discussed in hardware. Timer, if not timer, that means the time is not out. Time is still continuing. If we have defined any timer, let's say 10 seconds or 12 seconds or 10 minutes, I don't know, depends on what we are going to do. So if the timer is not arrive its end, then this is the condition if not timer 1. If we start the timer, that means we set the timer to 1. So and then internal clock start to count. 1 second, second wise is 1, 2, 3, 4, and if you define it as a 10, if it arrives at 10 seconds, then T1 here in this example turn to the 0. That means the timer is not more active. So here the meaning that if not timer 1, that means if timer is 0. And on the other side, it means time is over. Oh. And if, let's say, the input 0.2 and 1.1, that means active. If there are 1, you know, all the address are working with 1 or 0, digital, according to the digital information processing system, and digital information, you know, 0 or 1, existing or not existing, and so on. So the execution part is, for example, it is the section of the sentence where the output is activated. So set the outputs. So when can we set the outputs? If inputs are, if the, let's say the conditioned inputs are active, and then we can set the outputs. Set the outputs means set outputs 1, huh? Not from 0. Like this here in this example. Then set Y1. That means this is the output. Y1 means in this example coil of a solenoid or solenoid valve, or then reset Y2. Is another definition for the solenoid, another solenoid, or jump to sentence 10, for example. This is the number of the tens, then to continue from the sentence 10, that means. And you may remember, maybe let's come to our example, famous example. We already, you know, you may remember, we prepared them small, simple mechatronic system, and in this mechatronic system, we already realized what is actuator, what is sensor, what is hardware, what is software, and so on. Now let's see it once more. Okay, here we have, you may remember, we have here then our actuators, like here the linear actuator and our sensors. And here you see the Y1 and Y2, huh? The Y1 and Y2, those are the coils for solenoid valve here, Y1 and Y2, and those are the output like you see here, Y1 and Y2. And we had another example actually. Open, and so. Is it that? This is no name one. Project one. Is it like this one? Okay, this is the electric. Let's our PLC. In hardware, we discussed our input module, input module, and the output module. And here we can, as you may remember, here we set the inputs and the light turn on. And if we set the second one, light turns off, and so on. Huh? So the output, input, and this is our PLC include the program software we are talking about now. But I was checking something different or looking for something different. File open, maybe 5. Let's see what's 5. Okay, yes, this is what I'm looking for. So this is really what I'm looking for. This is our hardware, you see. The simple mechatronic system consists of one linear actuator, and this linear actuator is a pneumatic cylinder and has two signal element sensors which are checking the end position of the piston or following let's say giving the signals about the end position. Sensor 1B1 for the initial position, and first sensor 1B2 is final position. And to drive these cylinders, a linear actuator, we have a valve here, you see, and this valve is to drive the linear actuator here. And this valve consists of is electrically actuated. It consists of two coils, Y1 and Y2, and those are the I mean the outputs like we mentioned it here. The output. So the then set Y1, the solenoid 1 set. That means set you have to make it 1, activate it. So if the Y1 is active, you can see here. If Y1 is active, what's happened? So if Y1 is active, then the valve take this position. So the position close to the Y1, and in this position, the pressurized air connected, like you see here now. You see connected, and let's say the Y1. Let's check the Y1. Okay, if Y1 is active, then you see Y1 is active or not active. Then let's open the pneumatic energy. If Y1 is active, you see come in the twist position valve and piston moves forward. And then the sensor 1B2 in the front position of the linear actuator detect this piston and inform the control system via the signals 1B2 that pistons arrive in the front position to the front position, and then piston starts to move back. Okay. So then let's go again to our slides. Here, so it is really cold here, huh? So I will not come tomorrow. So the office is small. So the office is cold, unfortunately, and therefore to make the lesson in office is also not not good because of the cold. And so the signal sentence. So the signal sentence within a step. So now we have a step now. We talked the structure-wise consists step, sentence, and sentence consists. Each step consists of several sentences, and each sentence consists of a conditional part and executional part. So then here you see we have a step defined step. That means the step start. That means the start steps. So we can write here actually a small explanation, short explanation. What do we mean by that? Label for step can be up to 8 alphanumeric. So the name 8 alphanumeric. And step starts. So the first sentence of the step is the conditioning part. If input 0.0, the conditional part, then this is the executional part, then set output 0.0. So, and then we come to the final step, stop step. If the input 0.1 is active, then reset output 0.0. And the program works in so that program works step by step. So first step is start. If the start is finished, then program go over to the steps stop. But if the step 1 is not finished, so the program will stay there and will not change this step. So that's the reason why you say step by step. So if the previous step finished, then program go to the next steps or activate the next steps. If not, then stay in this step which is not completed. So single sentence with a step. So the program will execute the first step. That means here step start. And the condition 101 is true. So if it is true, then it will execute execution part, then set output 0.0 and proceed the next step to stop. So this is what I explained actually here in written form. If the condition is false, that means 0, not true. So, in logic communication, there are also two other definition, true or false. If it is true, that means it is 1. If it is false, it is 0. So if the condition is false, that means it's 0. It will wait at the step start, as I mentioned already. So multiple sentence within a step. So there is a step here, step start, and it goes here to this step stop. But step start consists of more sentences, not only one. So each of them is a sentence. If then, is all of them are sentences. But you see, we already said that, and this is the conditioning part here. If first sentence conditioning part, and the other one is the as you see, the execution part, then set output. So, and it works like this. First condition, then the execution. So here the second sentence, and it means if input 0.1, that means if it is true or if it is 1, then set output 0.0. That means the set output 0.0 to 1. Or the next sentence is here, if input 0.2 is active, then set output 0.2 and so on. And it could be also like this in the stop sentence. So if there's one condition and more execution, then reset. That means must be 0, huh? So reset means it was 1 and has to be turned to the 0. So deactivate it. Okay, if the conditional part of the first sentence is if the conditional part of the first sentence is true, that means is it 1, huh? So is it active? Is it existing? Let's say if the sentence includes that if sensor 1B1, then that means if sensor 1B1 is active, that means sensor detected something as it is on or 1. Then it will execute the execution part and proceed to second sentence without any exceptions. Yeah, and that means, so if input is 0.1 is active, is true, then the reset will continue. So without waiting for any signals. So if means condition. So condition means the PLC is waiting for inputs, and if inputs are available, that means the inputs related sensor is active or input signal is active, then it is okay for the PLC, and PLC can continue with the execution part. That means then reset, and so on. Okay. If the conditional part of the second sentence is true, then it will execute the execution part and proceed to third sentence without any exception, without any hesitation. Don't wait. So no waiting at second sentence. So multiple sentence within a step. Against we have some other command like here, if the conditional part of the third sentence is true, then it will execute the execution part and proceed to next step. If not true, it will proceed the first sentence, second sentence, and it will loop within this step. So generally, only when the last sentence within the step is true, it will proceed to next steps. So last sentence, it's go to the next sentence, and if it is okay, all of them, then turn to the next steps. If not, wait. So there is another command like otherwise here. Otherwise, that means otherwise. So, and it is in the executional part. These commands we use in the executional part. Let's say step starts, and we say if 0.0 is active, then set 0.0 output 0.0. Otherwise, that means otherwise means if input 0.0 is not active. So otherwise reset. So output 0.0. So that means we have one execution, the conditional part, or the condition, one sentence for the condition, two sentence for the execution. And if we ask whether input 0.0 is 1 or not, so if it is 1, then set output 0.0. If it is not, that means otherwise, reset output 0.0. And then we can come to the step stop, and if input 0.1 is active, that means if it is okay, if it's true, then reset output 0.0. So the step execution with otherwise instruction means the program will execute the first step. Step starts. It starts with the step start. If the condition input 0.0 is true, then it will execute the execution part. That means set output 0.0 and proceed to next step. Next step means step stop. Otherwise, that means if not true, that means input 0.0 is not true. If not true, these conditions, first con, if not true, it will execute the reset output 0.0 and proceed to the next step. That means step stop. So this is the meaning of the reset. So let's make 10 minutes break, and we will start at 14:20. And I will not continue too much today because it is very cold here. Sorry for that. So maybe we make one more lesson, and then we will finish for today. So okay, let's continue. Huh? Okay, we discussed the otherwise. If, let's say, like the program, if input is okay, I mean input 0.0 is correct, that means the 1 or true, then set output 0.0. Otherwise, if not, that means if not. Otherwise, then reset output 0.0. Okay, so then in this case, there is no waiting at step start. So we don't wait in step start because either it executes reset or reset. There is two possibilities, and two of them are defined already. If input is true, then set. If input is not true, then reset. Input can be only true or false, so 1 or 0. And for each case, there is a definition. If it is true, set. If it is not true, otherwise, reset. So, and commonly used terms here, that means the comment in the PLC, in statement list. You see, the developer program or software developers are already worked on that. 200, I need the power. Okay, power cable. So that the program developer already tried to make it as simple as possible for the user, I mean for the programmer, because the to write a PLC program, it's not something easy. Especially if it is if we have a complex system, complex mechatronic system, so it is really not so easy to write a program. So we have to think in many directions and many possibilities. Control system is not something, let's say, this easy or simple. It is related also to the safety, environment, human, and the material, and so on. So it is getting cold. But in order to make for the user as simple as possible, they define certain commands, and they are trying to explain a simple language and to explain someone what you want and what do you want and what is the what is your expectation and so on. So one of them is the if. We already we have seen, we have learned, and other one is the then, and, or, set, reset, otherwise, jump to, not in operation. So not in process or not operation and so on. So let's come to the ladder diagram. So ladder diagram, you may remember at the beginning we said there are two types of programming. So some programming languages. So one of them is the statement list, statement CTL, statement list. The other one is the ladder diagram. Ladder diagram. So ladder diagram. And now we will talk about the ladder diagram. What is the ladder diagram? So the ladder diagram elements Also, like statement list consists of conditional parts and the executional parts here. And the structure is quite interesting. Mainly the electrical engineers use this type of use this program because it seems like the circuit diagram. And the condition part is on the left side, you see now, and the execution parts on the right side. Left, right, left, right, left condition, right execution. You see, it is like a circuit diagram. And on the left side, this is the left side, and this is the right side. Let's say this is the right side. So here you see an open contact, means an open contact here. Huh? So the S1. S1 is the parameter for the input. This input can be 101, for example, here like this. Input 0.0, for example. This is symbolic name, S1. So we can define, we can have a cross-reference list and of the reference list, and in these references we can define actually, we can define like this. We can give a symbolic name to the PLC address. And here is output. This is the output on the right side. Let's say 0.0. This is the output, like this. So there are user software. You can use this software and write such a program, such a ladder diagram, for example. And already mentioned it here on the left side. Here we have the conditional part, and on the right side here we have the right side execution parts. So what does it mean now? It means for us, it means if S1 then set Y1. So we can write like this. If the meaning of that, so if S1 then set Y2. This is the first sentence, and this is the second sentence. So what is S1? So we have somewhere a list, reference list, let's say. Here, let's say reference list, and this reference list we have to declare for the PLC or for this program. And in reference list, input 0.0 symbolic name. Symbolic name is S1. We can use both of them because the PLC knows all of them. We have explained to the PLC using a reference list. So then output, let's say the output 0.0, for example here, is Y1. So this is possible. We can prepare such a reference list and upload into the PLC, so PLC know that. like in our program. This is ladder diagram, but this, I said there are many other programming language. So I will show you the reference list. Maybe in our program you can see that here. Okay. Logic model here, T1, we said. Okay, cancel, edit. So it's not here, not in this example. Road trip should be favor of not. On delay relay, T1 sequence timer we use. Okay, this is not what I want. Okay, then come back. This is another. This is what is 5, isn't it? Here, English. Manufacturing. This is another program, and I will check whether it is. Yes, you see here the reference list. Can you see that? So let's go there and see that. You see the reference list here, related page. So this is the input address here. Input 0, input 1, input 2, 3, 4, and this is the output here. And you see input 0 input 0 is also identified with the symbolic name ST, and input 1 is identified with the, we can change it, but it must be, I mean, the also defined in the program. And you see now, you see here, let's make it seenable. So how can you make it seenable? Here maybe view standard view details. Not. Okay, here. So maybe. Okay, here. So you see here we have Y1, Y2, Y3, 4 on the on our circuit diagram, and connected to the PLCs to the outputs. So therefore it must be also known for the PLC what means Y1 and what means Y and so on. Therefore we need such a reference list. And here we use the symbolic name already. ST start button and 1B1, 1B2, and so on. The sensors are defined, or the symbolic names of the sensors, or the symbolic names of the coils here, the solenoids. And we have to declare for the program that the program know that. Okay, so then open files. So this is what we are talking about. So, okay then. So the ladder diagram, this is the input part and the output part. Okay, we said let's continue. The conditional part, if, for example, like this here, this is a conditional part, if, and this is the executional part or the execution part. Conditional part, execution part. Here we have output and here we have input, like we learned also in statement list. So the ladder diagram programming, when using a ladder diagram for programming, remember that it is a scanning program. So this is really a scanning program. Scanning program. So why it is a scanning program? So it is a scanning program. Why? So this means that the program will read from one rank or to another, regardless whether the condition of the previous range was fulfilled or not. So rank, we call the rank here. So each of them is a rank, like this here. Rank path, each path. So, and of course, with one part, the program cannot be finished. There are many parts, many ranks. So, in program, in case of ladder diagram, program will continuously all rank one by one, not wait whether it's fulfilled or not. So this is the interesting part of the ladder diagram. But you have another possibility. You have also some possibilities to organize your program, like we learned in step-by-step programming. So that's the reason why this means that the program will read from one rank to another, regardless whether the condition of the previous rank was fulfilled or not. Like here, for example, rank 1 and rank 2 and rank 3. So it starts from the first one. You see here, if S1, then set Y1, rank 1. If B2 is a sensor, I guess, then set Y2. So if B1, then set Y3, rank 3. But the program will not wait for a certain rank, meaning that whether it's fulfilled or not. It doesn't matter if fulfilled or not. The program is continuing to check all the ranks one by one. So from the from the ladder diagram, if B1, B2 is active, if B2 is active, Y will be set, regardless whether S1 was previously active or not. Like this is. S1 was previously active or not is not, not relevant. So, and the PLC is looking for each sentence one by one. And if B2 is active, then set Y2. If not, let's continue set. And if B1 is active, then let's set Y2, Y3, and so on. So ladder diagram programming, the conditional part could be, here we had On the conditional part, we had only one signal, for example. Here, not only one. You see, here we have, like previous one, if S1, then set Y1, okay. But there is two input here, S1 and B1. That means if it is connected in series, that means this is a logic AND. Logic AND. Huh? That means a logic AND. So, AND. This is AND. That means if S1 and B1 is active, then set Y2. And here you see the set means S means set. And if you set it, so that means in some places you have to check it. You have to check also the command for the PLCs you used. So here, if set means if once S1 and B1 gets true and PLC sets Y2 to 1, so then PLC keep it. Set means in that meaning, set means you set it and you need reset again for certain conditions. So here we see that two signals element S1 and S2 are parallel connected like this here. Parallel connected. What means that? That means this is an logic OR. Logic OR. Here, only here, huh? This part. So only here. Logic OR. So what means that? That means following. If S1, then set Y1. If S2, then set Y2. Both of them are acceptable. That means both of them, both conditions are relevant for the for setting of Y2. And another interesting application is, for example, logic NOT. That means not. And if you read it that way, if S1 is not, then set Y2. If S1 not. Or if not S1, I mean, so can like if we learned already in the previous example, if not S1. Sometimes use not, sometimes N. If not S1. That means if S1 is false, not 1, that means 0, then set Y2. Okay. So another important facilities we use in the PLC is timer. You see here. T means timer. T1 is T1 means timer 1, and depending on the capacity of the PLC, there are some timers to use in the program. So therefore, it is identified with 1, 2, 3, 4, 5, and so on. Huh? So timer 1, and what means that? That means following. Timer is set to the 5 second. So timer set to the 5 second. Timer 1 is set. So if S1 and B1, then set the timer. So timer start to work, to count. How long? Until timer finish the 5 seconds. So after 5 seconds, it turns off. That means timer, during this time, 5 second, timer is 1. Logic 1, true. If time is over, the timer will return to the 0. So, and to start the timer, that means it is a sentence or command to start the timer. The meaning of this ladder diagram is if S1 and B1, then set timer 1. Or if S2 and B2. If S2 and B2, so B1, set timer 1. So two-way. This is OR, you know, if there's a parallel connection, this is an OR, and therefore that means if S1 or S2 and B1, then set timer 1. So as we learned also in our hardware part, the PLC has to be connected to the current. So there we have the 24 volt direct current and our 0 volt. And since PLC is a electronic equipment, needs energy, electrical energy, that reason we have connect here to 24 volt and to the 0 here. So PLC needs power. Power 24 volts. Okay, direct current. Okay, let's. So there's another document, we discuss all of them, and I will continue from that. Okay, otherwise we always discuss, otherwise this is also okay. So the ladder diagram, okay. So, no. Software. Okay, yeah. So this is the tool, okay. Okay, this document is mainly about the statement lists or some other command we use in the programming language. So there are some definitions. You will, if you are interested to write software or to develop yourself in field of software, so some important definitions. You use operand, one of them. What means operand and what means certain vocabulary in the language of the PLC or PLC programming. Maybe we talk a little bit about. So here, operands means system identifiers are referred to as operands. So operands are elements within the controller that can be interrogated or manipulated using program instructions and operators. So absolute and symbolic operands. Absolute and symbolic. So the absolute and symbolic operands. The software allows programs to be written using both. That means absolute and symbolic operands. Example of absolute operands are input. We already mentioned in our previous discussion, input is the absolute operand. Because we use directly the address which is also known by the PLC. We don't use any symbolic definition. T1 is also absolute. Output 0.4 is also absolute operand. Absolute because PLC knows that. It is the same, let's say, the language PLC used. But the symbolic operands means symbolic names or symbolic operands. S1, for example, is symbolic. Timer is symbolic. It's not defined within the PLCs. Solenoid is also symbolic, and Y1 is also symbolic. And therefore, we said it needs a table like this. Here, the absolute operand, for example, absolute operand, and here is symbolic. So symbolic. So the absolute is, as we learned, for example, input 0.1. Symbolic is S1, symbolic operand. We can use, by writing the program, we can use both of them. But input 0.1 doesn't mean anything for us. That means for the site installation. Because we know it is an address which is relevant for the PLC, but not the user of the machine or somebody maintains the machine. He can understand what is start, what is stop, and what is coil, what is not, and so on. Therefore, symbolic operands are much more important for them. Or here we can write timer 1, is the symbolic name, timer 1, and here we can write timer like this here, timer symbolic, huh? Timer, okay? Timer, maybe timer 1, so in that sense. Or solenoid here can be, for example, output 0.0, because solenoid needs an output. Here we can write solenoid 1, and so on. Or instead of that, we can write Y1, for example. It's also possible. Or instead of, let's say, the output 0.0, let's write here Y1, for example. Symbolic name, absolute name, or absolute operand, symbolic operand. Single bit versus multi-bits operands, single bits and multi-bits. So bits, you know, the bits are very interesting, important unit we use in digital technique. 1 bit or 8 bit or 1 bit word or 1 word bit or kilobyte or gigabyte and so on. And we pay the money also accordingly. Huh? If you have internet at home, you have to pay. Sometimes they say, okay, you can use without limit. Sometimes they say you can buy, let's say, the 8 kilobyte and or 4 kilobyte and 4 gigabyte and so on. Huh? Gigabyte. So therefore, it's a unit. We measure the information, the transfer or the use. So the single bit means 0 or 1. It's 1 bit. And this bit could be 0 or 1. Can get 2 value, 1 bit. Okay, single bit operand can be evaluated as true or false. True or false in the conditional part of the program sentence, and can be set or reset in the executional part. This is in conditional part, executional part of the program sentence. Okay, for the conditional part, we say 1 bit means 1 bit can get the value true or false, and the output on the executional part or execution part can be get value set or reset. That means reset 0, reset 1. Is 1 bit. And could be also multi-bit operands. Single bit was multi-bit operands. So multi-bit operands, MBO, can be tested for value or compared to other multi-bit operands in the conditional parts of the sentences. In the executive part of the program, sentence, they can be loaded with a value, decremented or incremented, or manipulated by a rich set of arithmetic and logic operands. So here you see the single bit operands, input, output, flags, counter, timer maybe also, but timer needs more because it is not single operand. So input is this operand. Statement list means I. Syntax error, input and the number. And typical expressions if input 2.0. Output statement list opera form O. Syntax, if you write this, output 1.0 and so on. And flag, here the example, for example, if input 2.0, then set output and so on. And here we have flag, side of the output, we have flag. Flags are like internal relays. We use for the memory. We use to define certain information use somewhere in the program later, or I don't know, depends on needs. And the other one is the counter. And flag we as we symbolic we use the O for the output, and for flag we use F, and for the counter we use C. Counter comes from the words. So, and there are, so how can we write it here? Counter, then the number. Here flag, number and bit number. Here output, number and bit number. And you see here the syntax, typical example, how we write it. So if C3, that means set C5. If counter 3 is true, then set counter 5. That means set to 1, and reset means set to 0. True, false again. So for the flag, if flag is a 1-bit operand, if flag 7.16, that means the word 7-bit 16, then if it is true, then reset flag F9.3. Okay, here we have, for example, again multiple. We have here single bit operands like input, output, flag, counter, and here we have multi-bit. That means not 1 bit. So this operand have more than 1 bit. That is, for example, input word defined, or output word, or flag word, or function unit, and so on. And you see here, this is the statement, this format. We used input word, output word, flag word, and function unit. And here the how we write it, syntax. And here typical example: if input word 3 is equal value 200 to 255. 55, that means a word has a value, we can upload a certain value into the word, because bit has only one, one digit, one value is 0 or 1. But you may remember from the digital technique, I am sure you learned that. So it is like this. We write digital technique 2 is 0 or 1 or. So I should make a mistake. Okay, 1 or 0 or. Two and third, second, third position. And if we want to write a certain number, so we can say what means, so 1 0 0 1 1. What means that, for example? So this is a actually a number, and that means here, this means is here we have 2, and we have here 2 over 1, here 2 over 0, and here we have, this is 0, this is already 0, and this is also 0, but is 1 2 3 4, 2 over 4, and here we have 1, here we have 2, and here we have plus, plus, and here we have 64, is it? So dot, sorry, 16, must be 16. Let's take it away, and 2 over 4 means this is a position 4. 1 2 3 4. This is here plus 0 and 0, also plus here and plus here, 2 over 4, and 2 over 4 is the dot 16, then it's equal here, must be 16 plus 2 plus 1, so is equal 19, something like this. So with this, this is the abbreviation or indicating with 1 or 0. At the end, we can write a certain number using this for this form of writing. And for that, we need, for the word to write a certain number, so we need a input word. Or the input word consists of, let's say, the 8-bit in total: 1 2 3 4 5 6 7 8, 8-bit. And the double word and means 16 and 6, 8 and 16 and so on, in order to write certain values. Here, for example, for the flag, we write upload the value to 21,000 to the flag board 1. So that means there are some bits inside. So word is at least 8 bit. So this is not only 1 bit. So we use also in PLC these memory units to upload certain values or to use certain values or to use for the arithmetical operations and so on. So multi-bit operand, here you see timer words also. We can have timer words, or timer preselect, or counter word, counter preselect, and so on. And this is not a single bit. It needs more. If we have to write temperatures 27, you cannot write only with one bit. It is not possible. So you need more bit. Therefore, we use multi-bit operands. And register also another important multi-bit operands, registers. A register, that means we can use internal memory. We can upload some values in the register, and we can reuse it. So if register 16 value-wise equal 1113, then load register 53 and register 45 to register 32. So you make inside of the PLC some calculations, arithmetical operations. Therefore, you need some values, and these values can be upload and load and in registers or in certain flag words and so on. Or errored words, error. So the error, this is also used in automation system. If there is an error, so the error must be seenable. So that means the error number must be registered somewhere. And error is maybe you need the information about the error. Say the sensor 1 is defect. So sensor 1 is defect. How can you write sensor 1 is defect? So it needs multi-bit operands. Okay, we already talked this statement list structure, program structure, like step, sentence, conditional, execution part. So today's I will stop here. Dear students, it is quite cold here, and I'm getting, cold. And so next week, so we will have a midterm exam, and you are responsible till the hardware and software will be not included. So that means the actuator, sensor, networks, sensors, networks are included. So in this week, I'm waiting for the. I will go to the dean office now, and I will check whether we can the exams combined. Exams for the mechatronics students, midterm exam for the mechatronics students, and for the mechanical engineering students. Then I'm sure they will inform you, or I can also inform you if there's any change regarding the program. So, do you have any question? After midterm, we will continue. Okay, here's. So, do you have any question? Okay, thank you, Mohammed. Welcome. Okay. So see you tomorrow, and we will do online. The lesson we will do online. Okay. So bye bye. Have a nice day.